Why the hell are there like 4 objects involved with this? So I have my container, a vector, and then there is a table node, a container set. Well, okay, well that's 3, and then the 4th would be the graph. Hello, Ivan. I don't know if you come here more often, but I'll explain what I'm doing. Well, at least if I start to explain things, people leave usually, so I'll keep it short. I have this class C. Actually, I have class D. C works. I have class D, which has an array and another member. And normally I would do add node member B to add this member, and I have to do something else to add the array. And then that will be shown in a graph, the relationship between those things. So the add node member is quite straightforward, because the member itself, B, is just derived from rectangle node, which is derived from a node. So B is a node, and I can just do add node member for any node, and then we're done. Where is it here? Add node member. But now this one, add table node members. Because suddenly 2 other objects are involved, which you can see in the other example. So this is my member. It's now a vector instead of an array, but it doesn't matter. And this is the graph. But I cannot just add that to the graph. Instead, I have to add it to a table node, and the table node must be added to an indexed container set, and the indexed container set must be added to the graph. It's like a whole stack of things that have to be added to each other. Well, okay, you know, let's put this in a. I put it in a random order because I wanted to work no matter in what order you initialize things, but let's put it in a slightly more sensible order. Let's put a graph below other stuff, as low as possible, I mean. Yeah, I'm just doing a pushback to show that the difference between copy and link. Hey Brooks. If you do, yeah, I'm just going to use link elements, I think, for both. Oh no, not really. Let's do copy elements and then do that here and then we don't see that, or no, rather I have to do it in front of it. Yeah, but I'll move them here. And the edge can go all the way here. Now maybe move this one also down then. Like there. Okay, this is slightly less messy. So my actual container, the vector, has to be added to a table node. The table node has to be added to an index container set, which then has to be added to a graph. And in the other example that I'm writing, I already have a container, and I already have a graph, and I already have an index container set. Okay, so the only thing that's missing is the table node. Where should I create my table node, and where should I store it? That is the question, I guess. Try to remember how this works. So this container set we must add the table node to the container set, and the container set to the graph. So it's container table node index container set graph. So this is the container. Must be added to a table node, which must be added to an indexed container set, which must be added to the graph. And the index container set is something that is global-ish. It might be global, it might also not be global, so I decided to first implement the not global version, and then if I want it to be global, then I can just use a global thing instead of a local thing, and then it's global. So here I have my indexed container set, and that's the one that I want to use here. Now the index container set must be added to the graph. And since I have control over the, I being main, over the container set, I think I should also be the one that adds it. So that link is done. I create it and I add it here. That would be that part. But the table node, nobody has the table node yet. I would say it would be easiest if the table node is an element of class, aka the base class here. Your messages on Discord, let me see. I'm immediately making you public. Programma 1, new always inline, static void, CPU relax. If defined, else if defined ARM or defined Linux. No, that is of course not good, because then you might as well remove that. You could do and, but not or. Imagine you have a Linux running on yet another CPU, not ARM and not Intel. Now you would still do it. Would not be Intel and it would not be ARM, and but you would be running Linux, so you would still doing this. Well, this is ARM specific. So you have to remove this and find out why the hell that is not defined on your ARM CPU. So look at atomic flag lock. No, that does not make any sense whatsoever. This just must be the ASM line. So only this. Why do you add that? These two lines must be removed. Atomic flag lock. Yeah, you don't even use that here, so no, just delete that. Yeah, you cannot push to utils. You have to do a pull request. Or I can do it and then you can test it. But you're telling me apparently that just that is not working, so this is not defined on your machine. If that's the case, then you have to figure out why this is not true on your machine. M1 is supposed to be in ARM. No, it's not ARM 64, man. You have 32 bits. You have to test ARM 32 as well then. That was the whole reason why the benchmark didn't work. Your Mac is 32 bits. So that's why this is not defined. I guess that on 32 bits this also works. Yeah, I'm testing that as well. So you have to test both 64 bits and 32 bits. So this 64 bits, that must be replaced with probably ARM 32. I would guess. Okay, you can test that. Right, back to the table node. Where to store that? I could store the table node in class, but maybe I don't need it. So in class we would just have an empty vector waiting for adding table nodes. Or maybe you can just add a table node like this. Well, then I can only add one table node. I might even need more than one. I wanted to make this as least intrusive as possible. So without the class here. Yeah, I mean now you have to add the base class, and we have to add this. If I even have to end this, it's already pretty much. I'm looking at the wrong thing again. Sorry. Let's look at class D. Yeah, I guess I could, or should even put the table node here. Well, that would be the table node that belongs to AS. And then I can do add table node members, and then we just have multiple of these, possibly multiple of these. And I have to add my table, like link container AS. I think this should work. And that did belong to the AS thing, of course. Okay, then I have to make this work. Add table node members now adds a table node, literally dot table node. I think that add node member added a node or a dot node, a normal node. No, wait, that's a concept is node. Base of node. So that's a CVB graph is node, not the dot node. Yeah, in this case maybe I don't need it. I don't need an extra class in the middle. So I need a concept is table node, and that is then dot table node. And an add member, and then we have to, I call initialize on that. That ain't gonna work then. Cannot do this here, I'm afraid. Maybe that's the reason I need another table node in a different namespace. Yeah, definitely. That's also the case here. So we call initialize on it, and then I get the dot node from that node for adding it. Kind of like this, I guess. And this then just calls that function multiple times for each element, for each argument. Okay, so we need a table node like that. Which then need to write. And it needs to have an initialize. And the initialize must be passed on to what actually? It feels like I have to pass the initialize onto all the elements of the array. Ouch. I can do link on. I can do link container if this thing is derived from the dot table node. But then the question is if my initialize can access the container. So the link container here stores stuff in table node data. So that would be dot table node data. And here's my. No, it's not true. I can use this function to access table element objects as function of the index. Need to add more stuff to it then. The right HTML was using it. Okay, so like this I can access table elements, but I think the container reference is a private. Do we need to have an accessor for that or something else? Maybe make it protected. No, that doesn't work because it's a table node. I only have a pointer to this thing. Let me see what table element is. A table element allows me to get to the node through a const reference. Initialize is not const, so that won't work. Difficult. Ivan, yeah, because I got used to that. It's a bad habit, I guess. I mean, libraries, as in libraries written by myself. All of these files are written by myself, and I started to use double quotes way in the past to make a difference between system headers to installed on my system, third-party libraries, and my own libraries. But it's not correct in the sense that you should only use double quotes when you want to do it. When you want to include something that is relative to the path of the current file. In this case, that actually works for this one. But even this one should be like that. It just has its minus I path stuff to pick up the sys. So it's nothing relative to the current file, current source file to it. But yeah, I don't know. I'm just so used to it. So in my case, the double quotes mean that I wrote the file. Okay, I added a D and called initialize. So I have to add D to the graph. And that should work, right? So main is complete now. Calling initialize. It's actually the construction of D. Construction of D is not completed because this probably doesn't work yet. B is being added, and class also implements the initialize, I think. Initialize. Okay, that just sets the attribute of the subgraph that makes up the class. By calling the virtual function node attributes, so we get to the most derived class, that would be D. So this is being called first, which adds attributes, and then calls the base class node attributes. And then eventually we return from that initialize. But so the initialize, the only thing initialize does is handle the attributes. Now note that add node member does also call, what the hell? So add node member also calls initialize on that member and adds it to this subgraph in this case. Well, this is class. Yeah, of course it is. Okay, so now we also provide a table node here. I say link container AS. And then we have to add that table node to the index container set. No. Yes. No, this link is still not established. I cannot do that here because I don't know what the index container set is yet. Oh, I'll be right back. Someone's calling my doorbell. Oh, and there's a beeping. Give me another minute. I have to empty the. What is it? Washer dryer. Yeah, I'm back. Yeah, I don't hear the doorbell with my headphones on, nor do I hear the washer dryer with my headphones on. I like it. Don't hear anything. Yeah, well, I'm stuck here a bit. I don't even have my index container set. What to do? Yeah, what to think about this? Seems you can hardly get around adding a constructor argument here, right? Maybe I should make my class a template that allows me to add an arbitrary number of index container sets to it. Mm-hmm. It's kind of like this, I guess. Add a table node anyway. Can also add a reference to the container set. Oh, what's my ace? Oh. Yeah. If we can get something to work, that would be nice. And then maybe from there I can improve it. Alright, and table node must have an initialize as well. Ouch, yeah. So I need to write a new table node. So this one should be double quotes, because this dot is relative to the current directory of this file. Yeah, I'm going to need some kind of initializer here. Oh god, it's a hint to the compiler that you don't want to. Well, hint. I mean, if if it's supported, then the compiler will not include that header twice, parse it twice, whatever. Just kind of replaces, or it doesn't really replace, but you know, the header. It's like a header guard. Not exactly the same, but I don't use header guards anymore when I can avoid it. I just use the pragma ones. I believe it works something like if it, as soon as it encounters pragma once in a file, then the next time it encounters an include of that file, it doesn't include it. Yeah, now I have a table node as a template parameter as well. But the whole complaint was bullshit. Well, not really, I guess. But the main point is that I don't have this concept defined. Yeah. What is it now? Yeah, table node members. Is defined here. Or not. No template named indexed container set. Remember them add in index container set. It's called add container. Non-constant expression cannot be narrowed from size type to int. I don't see where the int comes from. I mean, unless index type would be an int, but it isn't. At least I hope not. What is container? It would be so nice if it told me. I'm guessing that is that, which in itself is strange because that should have 3 template arguments. Why does it only have 2 arguments? So then the question is, where does it come from, that utils array? I would guess this is class members test, so then I probably have to look at this. We're adding AS. AS is an utils array A3 ANX with 3 arguments. And maybe it left that one out because that's the default value. So let's make a struct a category. So yeah, and so now we're talking about something at least with 3 arguments. So that wasn't it. and it says as far as I know, if container is this, then index type is this. And basically it says that you can only construct an array index from an int, as far as I understand this, which seems like nonsense. Holy fuck, it's true. Why the hell would I do that? If you compare that to, say, a vector index, it's not vector index. Vector index has its own header these days, apparently. Star index. Yeah, strange. So the explicit constructor for the vector index takes a size type. And for the array it takes an int. That was confusing me, because I thought that that would be the same. I'm even storing it as an int. Yeah, well, I guess, I don't know. I have no clue. Okay, then we want an int for arrays. Let's see if I can fix that then. Instead. No, we cannot. That is... No, it depends on index type then. You see, I have a problem with using size type on a 64-bit machine for an index, because it's just ridiculous. Theoretically, I guess it's possible that you have more than 4 billion elements, but I do have that many image, 4 gigabytes if you store bytes, so yeah. Gotta wonder if an unsigned int is usable. That would also be a narrowing conversion for that matter. Although I have the feeling that this narrowing conversion is more about sign than about size. No, actually not. Yeah, well, maybe. I mean, we go from 8 bytes now to 4 bytes, so definitely narrowing there. So in that case, I have to use a static cast instead of trying to construct it or something like that. If that works, then I guess I'll go for that. No viable overloaded assignment. Because why not? Oh. Oh. Confused. A container is not returning a table element. That makes sense because it isn't. Why would the other one be returning that then? Table elements are just a wrapper around a node. Okay. So you're telling me that the vector works, but an array doesn't? works. Wait. I don't know what it does, but I'm not seeing an indexed container set. What the hell? Different thing, man. I never wrote it to the file. Oh, I'm so stupid. Well, but yeah, it works. Okay, so now what? this. Yeah. What the? Cottage. Oh, like that. I put it on the wrong side. Because container reference is a function, stores a function that takes a type size type, and returns a table element. So if we specify that explicitly here, then I should get better error about why that is not possible here. Yeah, okay, yeah. Kind of expected it. It's just storing A's. What am I doing wrong then? The array is storing an A, not the table element. I don't get it. Why the other how that works in the other one? Yeah, store A as well. So link that to table B. Am I adding the wrong thing? No. Yeah, call link container. So A is derived from .node. So apparently I can create a table element from a .node, which is probably true. Yeah, that's totally true. So then I guess it doesn't work in this case because that I don't know. My A not derived from .node. My A is derived from rectangle. Oh, oh, yeah, it's derived from node, but that's not derived from .node. It has a .node. Hmm. Man. Okay, I'm going to try. Nah. I think it comes down to that I have to do the same thing for table node as I did for the graph, and then maybe even for the next one and the next one. In the case, all the cases where I have that, like that, aka edge. Well, just edge and table node. Okay. Oh, I hate this kind of changes, but okay, let's try that. Let's at the very least make something that compiles first, I guess. Okay. And then I want to change my table node. Maybe I should put it below table node then. How did I do that in the other one? I just defined it. How can I? Okay, I guess this works because it's a template. Yeah. Yeah, this is called DD. Let's call it a TD. Or something, not graph, table node, TND. So now data returns the template argument. There's something that I have to change, something else. Must be where it was added to the graph, I think. Just find the graph. Ooh, did I do that like that? Or not? Maybe I did. Yeah, this one. Yeah, add table node. Make that there. So that becomes then also a concept. Wow, hit in one. Yeah, this wasn't affected. Although I do have tables. Still works. So now I made that table node a template. Let's see what you can do then. For that one. I think I kind of duplicate everything, or what the hell? Maybe, oh, make table element and template? I don't know. So, yeah, doing as well. Yeah, I'm getting the feeling that I just want the table element to be a template argument. It's amazing in how short a time this became a very difficult project, complex project. When we started it was so simple. Now everything is concepts and templates and lambdas. But yeah, no, let's follow my intuition. Well, that I'm not sure if that should be a concept, but either it compiles or it doesn't. So okay, let's call it TE anyway for table element. Can make it a concept later if needed. So then we can store table elements. And something was already using it. Table node data. Wow. Yeah. Hello, Shoy. Want to know what more is using table node data outside of this function file. Fortunately, quite a lot. I should probably name it to table node data template. Not sure though. Probably not necessary, but at least that would be slightly easier to make this change. Yeah, I'll probably have to add a const here as well. I cannot remember anymore why that was necessary. Okay, yeah. Or not. Damn it. The graph data is not a template. Did I just make table node data a template? No. Yeah, that would suck. Yeah, I can't do that. It's just ridiculous. I mean, of course, I can make graph data now template as well. But got to stop somewhere. I don't believe in it anymore at the moment. So I think I was editing this. Cannot make this a template. No way. Right, well, initially you would think then that means that table element would, no, rather the container must return a node. But I really want to be able to pass CPP graph is node instead of a CPP graph is dot node. So it's just not possible. Let me start with deriving graph is node from dot node. Which I have been trying to avoid all this time. Initialize a private member of table node. Also, table node must be derived from table node. I guess for the same reason, or where are we? Yeah, I just removed the node here, so And it is, so that might already work then. Well, it links, but yeah, that's not going to work. Not even that bad. The main problem here is that in this table with, well, it has no labels and it is not added inside D. So this array here is a member of D, so it should be inside there. Let's first start to add labels, although I think that's just a matter of not having called initialized, and that's the main problem, I think. In principle, I should go shopping and buy more food. I mean, that was my other brain half. I tried to ignore it. But I should, yeah. Not necessarily immediately though. Let's make this work and then I go shopping. So D has an array as a member. Why is it not added as a member? Now B was added as a member because here. Therefore, A should have been added as a member because of attempt here. And if you go to add node member, then you see that that causes a call to node initialize. And it adds it to the subgraph. That's why it had a label and it was added inside D. Now we are missing both on this thing. But it was, the container itself was added to the table node. And the table node was added to container set, and the container set was added to the graph. It's just not added to the subgraph. It's not added to the correct graph, maybe. I don't know. There was the point of horror anyway. So I have a table node. I add the array. We add the table node to an index container set. That must have been added then to the graph. But wait a minute, that this is passed to the constructor. This. So we did that in main, adding it to the graph. Pass it here, and I add it to the graph. So I would say that if we do not call this at all, then we get the exact same output. Yep. So it kind of has no effect then, this call. Now we call add table node members on AS table node. Why would it be adding that instead of, say, something else? Oh, it is. I see one thing that's wrong. The container set. Oh, wait a minute. Oh, right. Yeah. No, wait. Yeah. Okay. I can't get it inside D. It's a general thing. General as in I define it here. So there could be multiple classes that have a member inside the inside this container. So it's not something that should be put into D. I could put it into D, but it's kind of silly because yeah, it's an instance. Another instance of D would put its member inside the same index container set. So I need to have it outside. I do need to have I do need to add an edge though to it. So let's concentrate on the labels first. Only the labels. Seems to be the only thing that is missing then, really, apart from the edge. But labels means I think I just have to call initialize on every element of the array. Well, I cannot do add container set here. I mean, the container set is an external thing, like I just said. So either I would call it on AS or I call it on that. And this makes the most sense, I have to say, because, well, that can be anything. An array or a vector. Or so probably this is the simplest thing. Okay, add table node members using a table node, but this is, unfortunately, well, this table node is derived from dot table node. I never implemented initialize. Okay, that's the reason then for the labels. I want to know what we get here. Yep, we do. So this thing should call initialize on all the elements in the linked container or the copied container. So I need access to all the elements as dot nodes. I made this template. I haven't even used that yet, or what? Well, actually, I think I did. No, I didn't. So we should not derive this from dot table node anymore. I should derive it from table node template, passing my own table node data, giving me more control over this. And then at the very least, I can add member functions that have access to protected members of graph item. As in data. And I want data to return my data, which is, that would be awesome, right? If I had my own data. Yep. Okay, so let's try that. So I'm going to derive this from table node template and then pass my own table node data, which you define here. It probably needs to be derived from table node data though. Dot table node data. See if that compiles. No, it doesn't. Yeah, that is exactly the same as for graphs. See, these functions looked very alike, but that one at the top, add graph, doesn't take a graph. It takes a graph data. And then a huge difference is that all the other ones, they emplace a node or an edge or table node. This one does not emplace a graph anymore, it emplaces a graph data. Looks like I have to change the others as well. Except, of course, that graph data is just this. And table node is a bloody template. Why? It's nonsense. This graph is also a template now. Yeah, so it is the same. As long as table node data is not a template. It's not. That is a scary change. Hello, Sonny. And Shy. Or did I already say hi to Shy? A valve conversion from const graph item blah blah to that. Well, I think that operation succeeded. Test it out. Wait a minute. This is not true. Well, it was almost two. Okay, tail no data. in a subgraph add table node must accept a table node template, but it doesn't anymore. I need to call data here, but I'm not allowed to. There must be an add table node that accepts table node templates. It accepts, however, graph item. Probably good enough. Table node template is derived from a graph item. So I don't have this anymore, but I don't care, I think, yes. Let's try this. Unknown type name concept is table node data. What would that be? That is defined in table node. It's all the same thing. Actually, it's defined in dot. Table node data undefined. What the hell? Table node data. Oh, initiated compiled. I can finally go buy food. If it works, right? So history. No label, yeah. Okay, nothing changed, but we made a lot of changes. So now if I look at my file here, not that one. So D calls add table node members. So this one. Okay, it calls add table node member. Didn't do that. I'm gonna call member because I only have one member. Which calls table node initialize. So we call initialize on a table node here, which is whatever we passed. In other words, we call initialize on the S table node underscore, which is a graphics table node. And it's still doing nothing whatsoever. Right, but now derived from table node template, which in turn is derived from graph item, which has data protected members. So if now I call data here, then one that is allowed and two that is returning a table node data, that one. Now my table node data contains a private function, unfortunately. Let's make it protected. Oops. So we can call data, and then we get this one, and then I can access that from here. Container size is 3. So we have all the 3 members. I'm pretty sure I can run over them now. Let's call this test here also initialize then. Initialize. And now I can run over size type I equals 0. I is less than the container size plus I. And then we can call the other one as well, container reference. With an I, which then returns a table element. And the table element, I can get a note from that. Do I have a non-const element here, table element or not? Do I get a copy of it? If I just get a copy of it, that would also not be good, or what? See, this returns a copy of a table element. You're going to be kidding me. Why? Yeah, why not? But if it is a copy, then look at the log here. Yeah. My container here is const. And that means that I'm linking a container that I'm not allowed to change afterwards. And remembering what I did yesterday on the graph, basically this kind of initialization just has to be made mutable. So otherwise, I don't want to think back about it. It was intuitive then as well. So I'm going to keep a const container. So I don't know. Oh my God, really? I think initialization just has to penetrate right through the constness. It's initialization. Why would I pass anything here non-const just because it's not initialized yet? It's fake, isn't it? Or shall I remove the const? How many link containers do I have in the meantime? The question is, of course, if the user is ever going to need to link a const container. Yeah, v1 is not const, so I could just link it while it's not const. It kind of depends where that call needs to be done, right? That's definitely not const. It's in the constructor. Yeah, maybe you can get away with it. Copy element is also non-const. Okay, that's removed const. So that should still compile then. Or rather, looks a bit different. Expected semicolon. Oh, sorry, I'll be right back. I have to open the door again. Yep. Or in big. Yeah, I was just coding this, so. No matching member function call to link container. It's a bloody const thing. How the hell is that const? The ace is just non-const, obviously. In the constructor. Totally non-const. That's a non-const utils array. Oh, never mind. We have more link containers. That compiles. What did I change? Change these things. Okay, so now my container is non-const, which means that this returns a non-const or is able to return a non-const reference to table elements. Which then I want to be able to store in my container reference. Man, it has it even in the name. I was not really referring to the elements, but yeah, well, whatever. So now I have a non-const table element reference by calling that function, I hope. Nothing is that easy. Non-const L value reference to type cannot bind to a value of unrelated type. Oh. Yeah. I just broke everything. I just broke it. No matching member function for call to push back. Oh shit. Good night, you Trong Kwang. Thank you for the compliment. Oh, look, shit. Yeah, I haven't done something stupid. I have a vector of table elements. Yeah. It's kind of problematic now suddenly to store references in it. Or can I? Well, actually I can. Maybe I can. Yeah, okay, I get it. This is nonsense. Not table. Table element references. I think I'm gonna change my mind. On storing a node reference, yeah? Yeah, it's extremely dubious. It's too dubious. Let's not store references. But I need a. This is. It feels like very dirty coding because. Well, ignore the move. Basically, I'm passing a const reference to a node, which I then make a copy of. And that is possible because, for example, I am passing a const element that is derived from a node. And that there's a strong hint here that it just means that you are not allowed to change it, right? I mean, it's just const. But I need non-const access to the data stored in this node. So node is derived from .node, which is a graph item, I mean, which has an intrusive pointer, which is non-const, as you can see. It's just data. And I can get access to that by calling data on a non-const object. So we do have access to the data here, and I can create an accessor for it that just accesses the non-const node. Which then allows me to call data on that and get access to the data object that it points to. So I made a const cast without using const cast. So yeah, it doesn't feel good. But I don't know how else to do it. So just store the node. It's basically just a reference counter node to the node data. So we keep an extra pointer of a reference count. Keep a pointer plus a reference count to the actual data, and then sneakily we build in that we can also get non-const access to it from here. But maybe it is allowed. Maybe it is allowed as long as I remove the const here. At least then the caller is aware that we have access. You cannot pass on a const node anymore here. Let's see what that does. It fucking compiles. Okay, that worked. Yeah, well, okay. Now, so next, completely forgot what I was working on in the meantime. Let's go here again. So we call add table node member, which then what it is here. Okay, we call add table node member, which calls that doesn't make any sense. This call doesn't make any sense. Well, adding it to subgraph. It is already added to a subgraph. That's what I said. We cannot add it to this subgraph. But okay, let's do it anyway. I want to see how that looks like. That anyway calls then initialize on my table node. So that would be not class, not this. It's just node. I don't know. Table node. Yeah. And then we have X. Okay, here that's where we were. So now I call container reference on the table node base class there, and that returns a table element, and the table element now contains a node. So, and that then gives us, wait a minute. I'm not happy. that returns a table element. And now a table element has a node. As long as my table element is non-const, I can get a node reference. So a non-const node reference to my node. So first I must be sure that my table element is, well, man, that table element is just a temporary. It's never const. No. Nonsense. Anyway, it's never const, but okay. Let's see if this works. So then I would have a sorry, yeah, that would be, must be a dot node. No warning about unused nodes, but for the rest, should just open this file directly. No.hpp. No, it's not even where I'm working yet. This one. Table node.hpp. Okay, now I have a dot node, which is a graph item, but I need the data. Were you the one who was called Sasha? Otherwise I forgot your name. Data. Dima. Did you tell me that before? I can't get this to work, man. I mean, I'm allowed to call these things now because I made them protected, even. 2 times. Yeah, well, sorry. You know, I have a bad memory. I wrote it down now, so maybe I can remember it by cheating from now on. Let's see. Yeah, so I made these things protected so I can call them, but then I cannot call data on it. I still cannot call data. So I think better solution here is to provide a lambda and then call a function on table node data. and have that call my lambda with the data of all the containers. So begin with, then it doesn't make any sense to make these things protected. And I'm not going to call them here. Instead, we're going to do a for all trick. For all elements, whatever. Now, some lambda is going to be called, and we get something passed. And what we get passed is data. But dot doesn't know anything about my table node data, of course. So that's going to be a dot table node data. No, not table node data, of course, sorry. No data. Now I have two node datas. Yeah, I just don't need this. Let me just so the node data here is dot. There's only one matching tag. You gotta be kidding me. How? I don't have node data? Of course I have node data. No, I don't. No, come on. Where's the bloody initialize? Node. Node has initialize. What? Okay, that's fine. I just pass the node back. Dot node instead of node data. So you get the node back. We cause that to my node. And then we call initialize on that. And then the for all elements must work. So you have to implement the for all elements inside the dot table node data. And then we probably contain something like that. Who was talking about data? Suddenly no data inside. I just have nodes. So it did work already then. Okay, whatever. Theoretically, I could get data, I think, here, because this is table node data in dot, which has access to the call, to the data call. But yeah, the only thing I get here is run over all elements, and then container reference gives me the element. Or it gives me a node element, and then I can call node on that, and then I get the node reference. I don't get a node reference, I get a node. Oh, no. Node returns a node reference these days because container reference is no longer const. And I'll call back with that, I guess, whatever, something like that. And then here we cast it to our node, and then I can call initialize on it. Now it compiles. If it compiles, it works. You know me. Unless it doesn't, and then it takes 5 weeks to fix it. Where's my test? Yeah. Oh. No. How is that possible? For all elements. I'll blame my static cost. Yeah, it's 100% pure bullshit what I'm doing here. Pretty sure it is, anyway. Yeah, I'm pretty sure it is. Not 100% sure though. And I really want to go shopping. I think I'm gonna go shopping anyway. And then I'll pick it up afterwards. Okay, it almost works. I mean, if people are mad at me for going shopping now, it really always almost works, as in I need to change a few lines of codes, and then the only thing you will get to see is that there are labels here, like a colon and then some number, and then I say, okay, it works, goodbye. So that's the only thing that you miss. And yeah, I'll just postpone that for a few hours. I'll be back later.